Good day, my dear learners in the senior high school. Today, we are going to discuss parabola in the conic sections. Before we start our session, here are the following objectives. Define parabola, determine the vertex, focus, directrix, axis of symmetry, and ends of latus rectum of the parabola with the center 0, 0. Determine the direction of the opening of the parabola and applications of parabola in real life. Let's have first an activity. In this activity, you are going to label the parts of the parabola, and these are the following terms that you are going to place in the given figure: vertex, focus, directrix, latus rectum, and axis of symmetry. I am giving you 30 seconds to answer the given activity. So your time starts now. Time's up. So this is the label of our graph in the parabola. So this is the focus, directrix, axis of symmetry, latus rectum, and vertex. What are these terms? A parabola is a set of all points in a plane which are an equal distance away from a given point and given line. The point is called the focus of the parabola, and the line is called the directrix, as you can see in the figure. The axis of symmetry of a parabola is a vertical line that divides the parabola into two congruent halves. The axis of symmetry always passes through the vertex of the parabola. The vertex of a parabola is the point at the intersection of the parabola and its line of symmetry. And the latus rectum of a conic section is the chord, line segment, that passes through the focus, is perpendicular to the major axis that has both endpoints of the curve. A parabola is a conic section. It is a slice of a right cone parallel to one side, a generating line. Like the circle, the parabola is a quadratic relation, but unlike the circle, either x will be squared or y will be squared, but not both. A parabola is defined as a set, locus of points that are equidistant from both the directrix, a fixed straight line, and the focus, which is a fixed point. You recognize the equation of a parabola as being y is equal to x squared or y is equal to ax squared plus bx plus c from your study of quadratics. And of course, these remain popular equation forms of a parabola. But if we examine a parabola in relation to its focal point, focus, and the directrix, we can determine more information about the parabola. We are now going to look more closely at the coefficient of the x squared term to see what additional information it can tell us about the graph of the parabola. Keep in mind that all information you already know about parabolas remains true. Let's talk about parabola with vertex at origin, point 0, 0. The axis of symmetry parallel to the y-axis. As you can see, in the figure at the right, we have the equation y is equal to x squared. We have here the conic form of parabola equations. Y is equal to 1 over 4p x squared, or x squared is equal to 4py, with the vertex at 0, 0, the focus at 0p, and the directrix is y is equal to negative p. In the example at the right, the coefficient of x squared is 1. So, 1 over 4p is equal to 1, making p equal to 1/4. Therefore, the vertex is 0, 0, the focus is 0, 1/4, and the directrix is y is equal to negative 1/4. The distance from the vertex, in this case, the origin to the focus, is traditionally labeled as P. The opening of the parabola opens upward. To explain further how did they get the value of P, as you can see here, in the example at the right, the coefficient of x squared is 1. Okay, we have here a is equal to 1 over 4p. Since the value of the coefficient is 1, that is represented by a, it is equal to 1. 1 is equal to 1 over 4p. Cross multiplication, therefore 1 times 4p is equal to 4p, is equal to 1. And then divide both sides by 4, therefore p is equal to 1/4. The vertex is 0, 0, the focus is 0 and 1/4, and the directrix is y is equal to negative 1/4. The leading coefficient in y is equal to ax squared plus bx plus c is labeled a. So when examining the coefficient of x squared, we are examining a. So 1 over 4p is equal to a, and with a little algebra, 1 over 4a is equal to p. P is the distance from the vertex to the focus. You remember the vertex form of a parabola as being y is equal to a, the quantity x minus h squared plus k, where h and k is the vertex of the parabola. If we let the coefficient of x squared, or a, equal to 1 over 4p and perform some algebraic maneuvering, we can get the next question. Looking at the figure, finding for the length of the latus rectum is equal to 4p. To find for the endpoints of the latus rectum, we have negative 2p and p, and 2p and p. For the focus, which is 0p, if the vertex is located at the origin, 0, 0. While the equation of the latus rectum, y is equal to p, and the equation of the directrix is equal to y is equal to negative p. Let's review the given equation a while back. Y is equal to x squared. The vertex is 0, 0, and the focus is 0 and 1/4, while the directrix is y is equal to negative 1/4. Finding for the latus rectum of the equation y is equal to x squared, we have negative 2p and p. Since the value of our p is 1/4, 2 times 1/4 is 1/2. And since negative 2p, the result is negative 1/2. And the focus p, or the value of p, is equal to 1/4. And for the other endpoints, we have 2p and p, 1/2 and 1/4. So let's have another activity. In this activity, you are going to find the vertex, focus, directrix, axis of symmetry, and ends of latus rectum of the given parabola. You are given 30 seconds to answer the given equation. And the equation is y is equal to 4x squared. So your time starts now. Time's up. So the answer for the equation y is equal to 4x squared, we have the vertex 0, 0, For the focus, we have 0, 1 over 16. The directrix, y is equal to negative 1 over 16. And the ends of the latus rectum, we have negative 1 over 8, 1 over 16, and 1 over 8, and 1 over 16. I'm showing you the solution in solving for the focus of our parabola. Y is equal to 4x squared and the vertex is 0, 0. There are two ways in solving for the p of our focus. Y is equal to 1 over 4p x squared or x squared is equal to 4py. Let's have first y is equal to 1 over 4p x squared. Since a is represented by the coefficient and our coefficient is 4, so 4 is equal to 1 over 4p. And then cross multiplication, we have 16p is equal to 1. Divide both sides by 16, therefore our p is equal to 1 over 16. Same process with x squared is equal to 4py. Finding for the value of p is equal to 1 over 4a. And substitute the value of our a, which is 4. 1 over 4 times 4 is equal to 1 over 16. Therefore, the focus is 0, 1, and 16. The directrix is y is equal to negative 1 over 16. And the ends of the latus rectum, we have the positive and negative absolute value of 2p. And since our p is equal to 1 over 16, so 2 times 1 over 16, we have 1/8. Therefore, the ends of the latus rectum are negative 1/8, 1 over 16, and 1/8 and 1 over 16. Let's have another equation. Y is equal to 2x squared. So you have 30 seconds to find for the vertex, focus, directrix, and ends of latus rectum. So your time starts now. Time's up. So the answer for that, we have the vertex 0, 0, focus 0, 1, 8, and the directrix y is equal to negative 1, 8. For the ends of latus rectum, we have negative 1/4, 1, 8, and 1/4, 1, 8. For the solution in solving the equation y is equal to 2x squared, we have the vertex 0, 0, and the focus y is equal to 1 over 4p x squared or x squared is equal to 4py. Since the numerical coefficient of our equation is 2, substitute the value of a in the given equation. A is equal to 1 over 4p. Since our a is 2, so 2 is equal to 1 over 4p. Cross multiplication, we have 8p is equal to 1. Divide both sides by 8, therefore p is equal to 1/8. For the next solution, we have p is equal to 1 over 4a. Substitute the value of a, and that is 2. P is equal to 1 over 4 times 2. P is equal to 1/8. Therefore, the focus is 0, 1, 8. And the directrix, y is equal to negative 1 over 8. To find for the ends of the latus rectum, we have the positive negative absolute value of 2p is equal to 2 times 1/8 since the value of our p is 1/8. It is equal to 1/4. Therefore, the ends of the latus rectum are negative 1/4, 1/8 and 1/4, 1/8. Let's have another figure. What did you observe in the given figure? The opening of the parabola opens downward, isn't it? Very good. Looking at the equation, we have x squared is equal to negative 6y. Let us equate that form into y. So y is equal to negative 1 over 6 x squared. Looking at the coefficient of the equation, we have negative 1 over 6. That indicates the negative sign indicates the opening of the parabola is downward. Let's find for the value of p. How did we get the p negative 3 over 2? As you can see, p is equal to 1 over 4 times negative 1 over 6, which is the coefficient of the equation. P is now equal to 1 over negative 4 over 6. And then, get the reciprocal is equal to negative 6 over 4. Simplified, that will become negative 3 halves. So the focus of the given equation is 0, negative 3 halves. While the ends of the latus rectum, we have negative 3 and negative 3 halves, and 3 and negative 3 halves. While the directrix of the equation, we have y is equal to 3 halves. Let's have another activity. Again, you are going to find for the vertex, focus, directrix, axis of symmetry, and ends of latus rectum of the given parabola. Let's have the equation y is equal to negative 4x squared. You are again given 30 seconds to find for the vertex, focus, directrix, and ends of the latus rectum. So your time starts now. Time's up. So for the answer in the equation y is equal to negative 4x squared, the vertex is 0, 0, focus 0, negative 1 over 16, directrix y is equal to 1 over 16, and for the ends of latus rectum, we have negative 1 over 8, negative 1 over 16, and 1 over 8, and negative 1 over 16. Since the coefficient of the equation is negative, expected that the opening of the parabola is downward. In the equation y is equal to negative 4x squared, since the numerical coefficient of our equation is negative, the opening of the parabola is downward. The vertex is 0, 0. Finding for the focus, we have y is equal to 1 over 4p x squared, or x squared is equal to 4py. A is equal to 1 over 4p, and the value of our numerical coefficient is negative 4. Negative 4 is equal to 1 over 4p. Again, cross multiplication, we have negative 16p is equal to 1. Divide both sides by negative 16, therefore, p is equal to negative 1 over 16. For the another way in solving for p, we have p is equal to 1 over 4a. Substitute the value of a, which is negative 4. So p is equal to 1 over 4 times negative 4. Therefore, p is equal to negative 1 over 16. The focus of the given equation is 0, negative 1 over 16. The directrix is equal to y is equal to 1 over 16. Finding for the ends of the latus rectum, we have the positive negative absolute value of 2p. Since the value of our p is negative 1 over 16, disregard the negative sign since we are looking for the absolute value. 2 times 1 over 16 is equal to 1 over 8. Therefore, the points or the ends of the latus rectum are negative 1/8, negative 1/16, and 1/8, negative 1/16. Another equation, we have y is equal to negative 1 over 4 x squared. Find for the vertex, focus, directrix, and ends of the latus rectum. So your time starts now. Time's up. For the equation y is equal to negative 1/4 x squared, the vertex is 0, 0, focus 0, negative 1, directrix y is equal to 1, and the ends of the latus rectum we have negative 2, negative 1, and 2, negative 1. The opening of the parabola opens downward since the coefficient of the equation is negative 1/4. For the equation y is equal to negative 1/4 x squared, we have the vertex 0, 0. Finding for the focus, we have y is equal to 1 over 4p x squared, or x squared is equal to 4py. A is equal to 1 over 4p. Substitute the value of our coefficient, which is negative 1/4. Negative 1/4 is equal to 1 over 4p. Finding for p, you simply cross multiply. Negative 4p is equal to 4. Divide both sides by negative 4, therefore p is equal to negative 1. We also have another way in solving for p, and that is p is equal to 1 over 4a. P is equal to 1 over 4 times negative 1/4. P is equal to 1 over negative 4 over 4. Simplify negative 4 over 4. Therefore, p is equal to negative 1. The focus of our equation now is 0, negative 1. And the directrix, we have y is equal to 1. Finding for the ends of the latus rectum, we have to get the positive negative absolute value of 2p. Since our p is equal to negative 1, so 2 times negative 1, negative 2, and finding for the absolute value of it is equal to 2. Therefore, the ends of the latus rectum are negative 2, negative 1, and 2, negative 1. To sum up our session for today, vertical parabola, if the vertex is at point 0, 0, we have the equation y is equal to 1 over 4p x squared, or x squared is equal to 4py. Finding for the focus, we have 0p. And for the directrix, we have y is equal to negative p. It is very important to determine first the focus of our parabola so that you could find the directrix and the ends of the latus rectum. If p is greater than 0, the opening of the parabola opens upward. And if p is less than 0, therefore, the opening of the parabola is downward. To determine the opening of the parabola, if a is greater than or equal to 1, the opening of the parabola opens upward. And if a is less than 0, therefore, the opening of the parabola opens downward. Let's have activity number 4. In this activity, you are going to determine the equation and the given focus, directrix, and ends of the latus rectum if the opening of the parabola opens upward or downward. You are given 30 seconds to answer the given activity. So your time starts now. Time's up. So let us now answer. In given number 1, the answer is downward. Number 2, we have upward. Given number 3, we have downward. Given number 4, upward. And for number 5, we have downward. Did you get all the 5 given? Very good. Congratulations everyone for a job well done. You have answered all the 4 activities given to you in this today's session. In this activity, you are going to determine the different examples of parabola which can be applied in real life. I am giving you 15 seconds to determine which of the following images represents a parabola. So your time starts now. Time's up. So let us now check which of the following images is an example of a parabola. Did you get all the 4 examples of parabola? Very good. In a clean sheet of paper, I want you to answer these questions. What are the different parts of the graph of a parabola? What are the process in finding the foci, directrix, axis of symmetry, and ends of latus rectum of an equation of a parabola? And what other examples you can give that applies to parabola in real life? For your assessment, you are going to complete the table. You are going to find the vertex, focus, directrix, axis of symmetry, and ends of latus rectum of the given equation. We will be checking your answer to our next meeting. Again, congratulations everyone for a job well done. That ends our session for today. For more activities, please click the link below the description. Again, this is your math teacher, Teacher Charmaine, leaving you an inspirational quote by Paul Halmos: "The only way to learn mathematics is to do mathematics." See you in our next session. Bye!